Because my work is highly seasonal, and with summer approaching, I currently have very limited time to continue work on the boat alongside my other projects, especially renovating the house the boat is being built in, which I jokingly refer to as wharf among friends. For that reason, the video is a shorter update compared to my usual uploads. Most of the work shown here consists of sanding and hull fairing using epoxy filler, which, while important, is not visually the most exciting stage of the build. The overall construction method for the hull was based around using a very light and flexible Depron foam sheet as the primary core material. The goal was to rapidly establish the hull geometry with minimal initial bodywork, then laminate the structure with fiberglass and epoxy resin. After curing, the hull had the basic shape and structural integrity, but the surface finish was still relatively rough. In this construction method, the actual fairing and precision bodywork happens after fiberglassing rather than before it. Despite the additional finishing work required later, I genuinely like this approach because it allows the project to resemble an actual boat very quickly. Psychologically, that is a major advantage for morale during long builds, even if the boat crew currently consists of only myself and the occasional help of my mother or girlfriend. Over the course of this stage, I used approximately 3 to 4 kilograms of epoxy filler, or 60 to 80 euros. Unfortunately, sourcing marine grade materials locally is not always easy in my area. One thing that became very clear during this process is how aggressive fiberglass and filler dust can be. Proper respiratory protection is absolutely essential during long and hard sessions.
That's what she said!
For sanding equipment, I use several different tools depending on the type and scale of the imperfections. For larger surfaces and heavier material removal, I used a rotary sander, although I was quite dissatisfied with it because the sandpaper attached only with Velcro frequently came loose during operation. I also used a smaller, budget orbital sander which did not do much at all. In many situations, hand sanding actually proved faster and more effective. At the time of recording this narration, the majority of the hull fairing work is already completed. Only a few small imperfections still require attention. Overall, the hull is now approaching readiness for the next construction stages, which is extremely satisfying considering the amount of labor involved. Hull fairing is one of those processes where the workload increases dramatically depending on the desired final quality level. Early in the project, my goal was always to achieve the highest practical level of scale accuracy possible. That remains the objective, although there are still areas where even more realism could theoretically be added. One example is the propeller shaft arrangement. On the real Viking 50C, the shafts exit the hull and continue unsupported for a short distance before being held again by external shaft struts and bearings. Reproducing that same system accurately would have required manufacturing completely custom propeller shafts and support hardware from the beginning of the build. Interestingly, a fellow builder is currently implementing a similar free-running shaft setup on a different vessel. In full-scale boats, including many wake boats and sport fishing vessels, this shaft configuration is actually very common. In hindsight, this is something I would seriously consider implementing in a future project. Unfortunately, it was a detail I only fully noticed after the cut work and hull construction had already begun. The good news is, it is mostly a scale detail issue rather than something that significantly affects performance on the water. Another correction I made during this stage involved the cockpit floor geometry. In the previous video, I discussed adding a slight convex bosh to the cockpit sole to improve the water drainage. While many real boats use this feature, after studying available reference photos of the Viking 50C more carefully, which are very limited, I realized that the actual cockpit floor appears essentially flat. As a result, I removed the bulge again using an angle grinder. This also became an interesting demonstration of how rigid the fiberglass laminate already is. The stern section of the boat, which is one of the most defining design characteristics of the Viking sport fishing boats, received a particularly large amount of attention during the fairing process. Considerable amount of time was spent into sanding and refining those surfaces. Many Viking boats can also be specified with extensive teak or wood finishes around the cockpit and transom area. Personally, I decided against replicating that on the stern for two reasons. First, the additional workload would be substantial, and second, I simply prefer the cleaner appearance without it. However, I do intend to incorporate wood finishes in selected interior areas, especially the cockpit flooring and portions of the saloon entrance area. That is a stage of the project I am very looking forward to. The tuner door at the stern is already fairly advanced in its cut development phase. Beyond that, most of the stage consists primarily of continued sanding and fairing work. During the process, I also discovered that the hull is not perfectly scale accurate in one area near the stern. Between the final two ribs, the geometry transitions at an unusual angle. After investigating further, I discovered that the original plans represented the stern section as essentially flat rather than having the proper V-shaped geometry. That design issue ultimately translated into the hull itself. Fortunately, this is mostly an optical issue and will likely be nearly invisible once the boat is in the water. I would prefer the hull to appear correct both in and out of the water. From a hydrodynamic perspective, however, I do not believe the issue will create any significant problems. The hull should still plan correctly and perform well overall compared to some of my previous projects, including a very heavy center console model with objectively poor hydrodynamic characteristics that still performs surprisingly well. This hull remains comparatively refined. After additional fairing work around the cockpit area, which in my opinion is one of the most visually important sections of the sport fishing boat, I also added further fiberglass reinforcement from the inside of the hull. Since the exterior surfaces had already been faired and treated, applying additional fiberglass externally would have created unnecessary work. Laminating from the inside, however, instead offered several advantages, including increased structural rigidity throughout the hull and ribs. The main reason for adding this reinforcement was that during sanding, I noticed that the forward section of the structure flexing slightly more than I was comfortable with. The additional internal fiberglass significantly improved the stiffness in those areas, however also increased the weight. And yes, I still have epoxy resin in my hair to this day, which is honestly not ideal. It actually got bad enough that I ended up cutting my hair even shorter than usual. Inside the hull, the bow thruster system had already been installed at this stage, so I needed to protect everything from epoxy dripping down during the internal reinforcement process. Despite trying to keep things controlled, it still became fairly messy in certain areas. That said, I'm extremely satisfied with the structural results. The hull is now significantly more rigid than before, and the construction has effectively evolved into a sandwich composite structure in many sections. Across most areas of the inside of the hull, I applied a second layer of fiberglass, and in some regions even 2 additional layers, primarily to improve stiffness and better integrate the hull skin with the internal rib structure. As you may remember from the first video, the ribs were originally attached to the Depron foam primarily using hot glue, which is admittedly a somewhat unconventional construction technique. Now, however, the ribs are fully bonded into the structure using epoxy and fiberglass reinforcement, which provides a far more robust mechanical connection. There are still a few hull plates in the forward section that I'm not entirely satisfied with structurally. I may revisit those after later depending on how much epoxy remains available during the end of the build. Another aspect that was very important to me during this phase was refining the hull edge geometry. During the initial fiberglass process, I was not fully satisfied with how rounded some transitions became, particularly the transition between the upper and lower hull sections. I wanted those edges to appear sharper and more defined, closer to the actual lines of the real vessel. Achieving that required additional filler work and significant sanding afterward, especially because filler material naturally tends to sag or flow before curing, creating excess buildup that later has to be removed again. Afterward, I spent some time refining the bow thruster cutout and began marking smaller imperfections across the hull using a marker. At this point in the build, the process has shifted into identifying and correcting very minor surface details individually.
Well, I've been chasing the sun since I was 10 years old. Felt the heat rise on my skin, and I've been on the run from a...
This means we are now approaching the final bodywork finishing stages, which is a very satisfying milestone. I also installed and test fitted the exhaust outlets of the boat, which will actually be functional in operation. The system is designed to discharge both water and controlled airflow through the exhaust tubes. The reason for that airflow is to simulate exhaust activity. I currently have no plans to install a smoke system on board. Instead, the injected air will create small bubbles at the exhaust outlets whenever they are partially submerged underwater, for example while reversing or sitting lower at the stern during docking. Naturally, the same setup was replicated symmetrically on both sides of the hull. next video, the project will move away from sanding almost entirely and focus much more heavily on installing the 3D printed components and mechanical systems. Propeller shaft areas and propeller cutouts still require some additional sanding and redefinement work, but overall I am very satisfied with the bodywork. From a distance, the boat has finally started to capture the characteristic appearance of a Viking sport fishing yacht, which is extremely rewarding to see after all the dust and sweat. I hope you enjoyed this slightly different style of update video. I know this episode consisted largely of sanding and bodywork, but I did not want the channel to go silent for 2 months while working through these stages. Let me know in the comments if you enjoyed these shorter progress update formats. The next video should be significantly more dynamic, as we will begin installing many major systems and 3D printed assemblies, including the rudder, drainage system, gutters, exhaust plumbing and additional onboard components. After several weeks of continuous sanding and fiberglass work, I am genuinely looking forward to moving into a different phase of the build again. See you in the next one. Take care.